In this video, we're going to continue solving exponential and logarithmic equations. Here's the first one. See how you do. By order of operations, I would have to multiply first and find the exponential value second. So here are my operations and inverses. I'll start here at the bottom of the right column. Take log base 10 on both sides and simplify. Divide by 2 and simplify. Here's my value and my check. Here's another. This time I'd multiply and then take natural logarithm. So here are my operations and inverses. Both expressions will become exponents for a base of e, and I'll simplify. And then I'll divide by 2 and simplify. There's my answer and my check. How about here? If t was a value, I'd multiply by -1, add 2, and then find the exponential value. That means I need 3 rows. Here are my operators and my inverses. I'll start by taking the natural logarithm of both and simplifying, then subtracting 2 and simplifying, and finally dividing by -1 and simplifying. Now, it's traditional, if the denominator is negative like this, that we multiply both the numerator and denominator by -1. So this will become negative natural log of a half plus 2 over 1. And we won't write this denominator of 1, so this will just become 2 minus natural log of a half. And here's the check. How about here? I notice first that I'm subtracting my variable, and so I'm going to rewrite that as adding an opposite. Then I'll build my 2-column table. By order of operations, I'd multiply by -1, add 6, take natural logarithm, and then subtract 35. Now, using my inverse operators, I'll add 35 and simplify. Both expressions will become exponents for a base of e, and I'll simplify. I'll subtract 6 from both and simplify. And finally, divide both by -1 and simplify. E to the 85th is such a large number, we just leave it like this. And here's the check. Try this one. If y was a number, I'd add 4. I'd find the exponential value. I'd multiply by 3 and then add 3.5. So here's my operations and my inverses. I'll begin by subtracting 3.5 and simplifying, then dividing by 3 and simplifying. Then both expressions will become an argument for log base 10, and I'll simplify. Last, I'll subtract 4 and simplify. Now this value's approximately -3.5. But when I go to check my work, I'm going to use the exact value. How about here? By order of operations, I would add first, find log base 10 second, multiply by 8 third, and then add 12 last. Here are my operations and my inverses. I'll subtract 12 and simplify, divide by 8 and simplify. Use both expressions as exponents for a base of 10 and simplify, and then subtract 1 and simplify. And the check looks good. Try this one. Again, we're subtracting our variable term, so I'm going to rewrite that as adding an opposite. Then here's my table. I'll start at the bottom of the right column and divide both by 2,500 and simplify. Then take the natural logarithm of both sides and simplify. subtract 1 from both and simplify. And last, I'll divide by -2 and simplify. Again, we have a negative denominator, so I'm going to multiply both the numerator and denominator by -1. That's going to give me 1 minus natural log of 3.2 all over 2. How about here? Again, we're subtracting the variables, so I'm going to change that to adding an opposite. Then I'll build my table. By order of operations, I would multiply first, add second, take log base 10 third, multiply by 6 fourth, and then add 7 last. So to undo my operators, I'm going to subtract 7 and simplify, divide by 6 and simplify, use both as exponents for a base of 10 and simplify, subtract 12 and simplify, and finally divide by -2 and simplify. And here's our last one. By order of operations, I'd multiply first, take natural log second, multiply by 2 third, and subtract 7 last. So here are my operations and my inverses. I'll add 7 and simplify, divide by 2 and simplify, use both as exponents for a base of e and simplify, and then divide both by 4 and simplify. Here's my answer and my check. Well, that will conclude this video where we continued with exponential and logarithmic equations.